Hi, welcome. Today we're going to go over lesson 3.5 over complementary and supplementary angles. So this is going to be a pretty quick lesson. There's not much in this lesson besides these two terms. So we're going to start out by defining it. So a complementary angle is simply two angles that have a sum of 90. Now supplementary is almost the same definition, except for it has two angles with a sum of 180. Now, some questions that sometimes arise is, what do these look like? The angles do not have to be adjacent. So what I mean is these two angles could essentially look like this, where these are adjacent. They share a side and a vertex. Or they could be non-adjacent, where together they have a sum of 90. So either way, it's the same, they're both complementary. So for my example, the first one is angle A and angle B are complements of each other. Angle A is 40. What's the measure of angle B? Well, this is your key. You have to know what a complement is. It is the angle that adds to the other angle to equal 90. So all you have to do is take 90 and subtract the 40 to get 50 degrees. So supplementary angles. So it's very similar. These two could be adjacent and have a sum of 180, or they could be two angles that are two separate angles that together have a sum of 180. So the example says angle A and B are supplements of each other. Angle A is 115. Find the measure of angle B. Again, you have to know supplement means it's the other angle that adds to the first angle to equal 180. So we're going to take 180 minus 115 to equal 65. Now, there are two theorems, and these should already be updated on your theorem and postulate sheet. The complements of the same angle are equal, and supplements of the same angle are equal. And again, we refer to these just as theorem 3 and theorem 4. On homework, you never have to write out this entire theorem. You just refer to it by the number. Now, the easiest way I can draw this out is something like this. Maybe. Okay. So angle 1, angle 2, angle 3. Let me fix this. Yes, here we go. I'll get it here in a second, guys. Okay, this is why I usually draw out the pictures beforehand. Now, what you need to know is angle 1 and 2 add up to 90, and angle 2 and 3 add up to 90. So, if angle 1 and angle 2 add to 90, and angle 2 and 3 add to 90, so let's write this out. Angle 1 plus angle 2 is 90. Angle 2 and angle 3 is 90. What we notice is they both have an angle 2 in common. That means angle 2 has to be the same measure. So the complement, both angles have the same complement. They have to be equal. Angle 1's complement is angle 2. Angle 3's complement is angle 2. Okay, so the same thing works for supplements. So if I have 180 degrees, angle 1, 2, 3. So these two equal 180. And then these two equal 180. So angle 1 and angle 2 equals 180. And angle 2 and angle 3 equals 180. They both have an angle in common. They both have angle 2 in common. So this is the supplement. So according to the theorem, the supplements are equal. Okay, we have one theorem to do, and we are finished with this lesson. Angle 1 and 2 are complements of angle 3. How do I know this? Well, they tell you in the beginning, so it's given. Now, because of this, and I know that they're complements, I know that angle 1 and 3 are 90, and angle 2 and 3 are 90. So it's the same situation that I was describing up here. And so I understand that we're dealing with complementary angles. So what definition is helping me understand that I'm really just having two angles that add up to equal 90. I'm not using the theorem. I'm not saying angle 3 is equal to angle 3. I understand angle 3 is equal, but that's not what this problem is asking. It's saying, how do I know that these two angles equal 90? Well, because I understand the definition of complementary angles. And because I understand this definition and I understand what complements are, I understand that two angles add up to give me 90. Now, remember, these are stepping stones. They're not separate islands. So when I see step 3, I have to look back at step 2 and 1 to figure out how to get it. Now, I see this here, and I see this exact thing here, and I notice they both equal 90. So can I take the 90 out and replace it with what this 90 is equal to? Sure. So I can take this 90 out and replace it with what this 90 is equal to, therefore making these two things equal to each other. And that is a case of substitution. Okay, again, these are not separate islands. Look at step 4 and look at the previous step. They're stepping stones. How, if this is my if, do I get to this then? Well, here's angle 1, here's angle 2. Where does the angle 3 go? How mathematically can you remove that angle 3? So if I subtract it away from both sides, remember properties, you do it to the left and right. This is a property. I'm subtracting from the left and I'm subtracting from the right. I am using the subtraction property. And notice I didn't write sub because this would be really confusing, subprop and subprop, substitution property and subtraction property. Okay, so now this is kind of what your book does. Notes, proofs. Now I'm going to show you a problem my Core 40 class did today that is very relevant to what we're doing. And this might be like a SAT type question. So it's really good to see other forms of geometry. So I have two angles here, and they are, this is not and, they are complementary. And the measurement of angle JKL is 2x minus 3, and the measurement of M and P is 5x plus 2. What we need to do is find the measure of each angle. Okay, so we have to kind of decode this a little bit, and we're going to write an algebra equation. So this angle plus this angle is complementary. Now we need to know how many degrees this is. Complementary means equals 90. So we're literally taking the first angle, and we're going to add the second angle, and we're going to set it equal to 90. Now we have values. Right in here, they give you values to substitute. So if I take out JKL, I can substitute 2x minus 3. And for the second one, I can substitute 5x plus 2. Now, algebra time. We're going to collect terms together. So 7x minus 1 is 90. Add 1 to the other side. All right, so let's pick up a calculator. 91 divided by 7 is 13. Now, you need to know that in algebra class, once you find x, you're always finished. But with geometry, once you find x, that means you have to go back up, read the directions and see if you have to find something else. What you do, this is find the measure of the angles. So we're just going to plug it back in. And the good thing is we can check our work easily because your two answers that we're going to find should add to 90. So the measure of JKL, I'm looking right here. Instead of x, I'm replacing it with 13. So 26 minus 3 is 23. And the measure of M in P, these are angles. Let's put the angle symbol in there. 5 times 13 plus 2. So 5 times 13 plus 2 is 67. Okay, so 67 plus 23 is 90. So I know I did the problem correctly. Okay, so we are officially finished with lesson 3.5. That is your only assignment today. So go ahead and get started on it and let me know if you guys have any questions. Thanks.